Maintaining your Cravo retractable roofs and drive systems. This video will show you the preventative maintenance checks that should be done on a regular basis. Since the roof system is a machine, it is always a good idea to do a visual check whenever you are in the house to see if all the leading edges are straight, since a mechanical problem will always cause one or more of the leading edges to become curved or bent. There are four major groups of components that should be checked every 3 to 6 months. The drive systems for the roof and internal curtain systems, the roof suspension wires, the roof curtains, and the motorized roll-up curtains. The drive systems used on the retractable roofs and internal curtain systems have been designed using stainless steel, aluminum, and hot-dip galvanized steel components to provide you with many years of trouble-free service with minimal maintenance, provided that the original installation was done correctly and preventative maintenance is performed regularly. The roof drive system comprises the following 6 major components: the motors, the drive shaft with pillow block bearings, the universal joints on the A-frame, rafter, and X-frame houses, the wrapping of the steel cables on the drive drums, the stainless steel drive cable tension and cable tension spring, and the delay brackets, tube carriers, and leading edge. The following is the recommended procedures for checking each of the drive components. Motors. Do a visual check to see if the gearbox is leaking oil. If it is leaking, tighten any loose bolts on the gearbox or replace the gasket and refill the oil. Drive shaft with pillow block bearings. The bearings used on the drive shaft are designed for high-speed applications but are only rotating 5 RPM for 5 to 30 minutes per day. The bearings are sealed, so they do not need to be greased unless the seals are broken and the grease is leaking out of the bearing. Number 3, universal joints on the A-frame, rafter, and X-frame houses. The universal joints are also designed for high-speed applications, but are only rotating at 5 RPM for 5 to 30 minutes per day. They are pre-greased at the factory and do not need to be greased. Number 4, wrapping of the drive cables on the drive drums. How the cables are wrapping on the drum is an excellent indicator of the drive system alignment. If the cables are wrapping nicely together when the roof is completely closed and retracted, then there is little risk of a cable malfunction at the drive shaft. To check the wrapping of the cable on the drums, close the roofs or curtain systems 100%. When the roof is closing, listen for a clicking sound like this. This sound is an indicator that the delay bracket is misaligned and that the drive cable is being pulled on top of itself when the roof is almost closed. Then check every set of drive drums to ensure that all the cable wraps are all wrapping neatly side by side. Or if there are gaps between the wraps, or if the drive cable is trying to wrap on top of the existing wraps. To improve the alignment, the delay bracket can be moved to the left or right. Alternatively, instead of moving the delay bracket, another option is to adjust the drive drums to rectify the wrapping problem. To ensure that you do not change the closing position of the roof, put a mark on the drive drum and the drive shaft. Then loosen the set screws. Realign the wraps by rotating the drum until the 2 marks are lined up. Then retighten the set screws. After you have checked all the cables with the roof closed, then retract the roofs again to check to see if the drive cables are all wrapping neatly side by side. Then close the roof once more to ensure that your adjustments have resulted in proper wrapping of the drive cables. Number 5, stainless steel drive cable tension and the cable tension spring. This is one of the most critical steps of the preventative maintenance check. The proper functioning of the drive system depends on there being sufficient tension in the drive cables at the drive drums, especially when the roof is retracting. The cable spring is attached to the drive cable coming off the bottom of the drive drum and is designed to take up excessive slack in the lower cable when the roof is retracting, to prevent the cable wraps on the drum from becoming tangled. To check that the cable spring is able to function properly, first close the roof and check to see that all the springs are fully extended 32 centimeters or 12 inches measured from one cable clamp to the other. If you have a 32 centimeter or 12-inch long delay bracket, then the cable clamps should be located at both ends of the delay bracket. If the delay bracket is 48 centimeters or 18 inches long, then you will see a mark on the delay bracket to indicate where the cable clamp should be located to extend the spring to 32 centimeters. If the spring is not fully extended, then loosen the cable clamp farthest from the leading edge. Extend the spring and then retighten the cable clamp. Do not adjust the cable clamp closest to the leading edge, since that would change the closing position of the roof. Now retract the roof 100%. The cable clamps holding the cable spring should now be a minimum of 20 centimeters or 8 inches apart. If the cable clamp to cable clamp dimension is less than 20 centimeters, it is recommended to retension the drive cable to stretch the spring. If the spring has fully collapsed, then it will no longer be able to ensure that there is sufficient tension on the drive cable, which would cause a major malfunction of the drive system. To retension the drive cable, never tighten the loose cable that is coming off the bottom, since this will change the alignment of the closing position of the roof. You adjust the cable tension using the cable coming off the top of the drum. To retension the drive cable, the first thing to do is determine if the roof can be retracted a further 15 centimeters or 6 inches, since when we tighten the cable coming off the top of the drum, it will retract the roof further. You need to check how far the roof can be retracted both at the leading edge in the middle of the system and where the leading edge is adjacent to a return pulley, since the travel distance in some systems is shorter where a pulley is located. If the roof can be retracted a further 15 centimeters or 6 inches at all locations, then you can proceed to retensioning the drive cable. However, if the leading edges cannot move back 15 centimeters, then you have to adjust the open limit switch to have the roof stop earlier so that there is 15 centimeters of travel available both at the leading edges in the middle of the drive system and at the pulley locations. After you have adjusted the limit switches to provide the 15 centimeters of travel, then you can proceed to retensioning the drive cable. To retension the drive cable, ensure that the roof is fully retracted. Connect a pipe wrench to the drive drum with the cable coming off the top and loosen the set screws. Rotate the drum to increase the tension in the cable, which will cause the spring to stretch, and the loop of cable beside the spring will start to disappear. Ensure that the spring has stretched fully or at least to a minimum of 20 centimeters or 8 inches. You can then retighten the set screws. The final group of components for the drive system is the delay brackets, tube carriers, and leading edge. Once you have verified that the drive shafts and cable are operating properly, then do a visual check of all of the leading edges to see if they are straight. Note that if the roof is closed part way, then the leading edges in the sections with the delay brackets attached may not be straight due to the movement of the delay brackets. This is perfectly normal and is not cause for concern. To verify that the delay brackets are properly adjusted, you will need to close the roof 100% and then check to see that the leading edges are fully sealed. If some of the leading edges are bent, or the roof is not closing fully, then it is important to determine what caused the leading edges to bend. Several errors that could happen during the installation include: the posts were not installed vertical, the suspension wires were clamped before the curtain was installed, causing a misalignment between the wires and the roof suspension hooks. When securing the roof curtain to the leading edge, the black tape was pushed up into the suspension wires, causing excessive friction, or the black reinforcing tape was not centered under the suspension wire, causing binding between the hooks and wires. The leading edge was not installed below the suspension wires. If the leading edge needed to be cut, the leading edge was cut too long, causing it to catch on a post, or cut too short, causing the leading edge to miss the last hooks. The eyes on the delay bracket were not closed, causing the delay bracket to become disengaged from the drive cable. Once the cause of the excessive friction has been eliminated, adjust the tube carriers or delay brackets to align the leading edges. If any of the leading edges are permanently bent, then it is critical that they are replaced. If a roof has over-traveled, causing the leading edge to become disconnected from the aluminum tube carrier, then the jaw or complete tube carrier should always be replaced, since the jaw will have lost its holding power. Roof suspension wires. The second major component to check are the roof suspension wires, which are made using heavy gauge stainless steel spring wire, which means that they will not rust and are resistant to stretching unless they are loaded excessively. Do a visual check to see if any of the roof suspension wires are loose or broken. Obviously, if any wires are broken, they should be replaced immediately, since the roof covering will fail prematurely if it is not supported by all the suspension wires. If the roof wires are excessively loose, then they will flex in the wind and are then prone to fatigue and break. There are three primary causes of roof suspension wires going loose: excessive load on the roof from a snow load, hurricane, or cyclone, walking on the roof, and movement of the bracing footings if the structure has exterior bracing cables. If the wires are loose, then loosen the wire retainers, retension the wires, and then retighten all of the wire retainers. If the roof wires are loose due to movement in the bracing footings, then this is a very serious issue and the affected footings will need to be modified. The roof curtains. To check the roof curtains, the most important thing to look for is that all the suspension hooks are connected to the roof suspension wires. When hooks are not connected, this will shorten the life of the covering, since the adjacent area will be exposed to greater loads and more fatigue. Roll-up walls. The motorized roll-up walls have only three main components: the motor guide shaft with counterweight, and the curtain with the drive tube and the bottom tube. The gearbox on the motor is lubricated using grease, so there is no need to add grease unless the gearbox is leaking. The following video will show you the key items to check on the motor guide shaft and roll-up curtain. When installing a sidewall roll-up curtain, there are several things to check at the completion of the installation. The first one is that there is 2 bolts connecting the drive tube to the output shaft. The second thing is that there are 2 self-tapping screws installed at the bottom leading edge of the curtain, and that the curtain has been pulled tight prior to the installation of the set screws. The third thing is that the cable is running properly through the 2 pulleys at the top. And the last thing is that this counterweight here, when the roll-up curtain is all the way up, should not be able to seat or touch this bottom guide shaft mount. And then when looking at the curtain, you should see that there's no major creases when the curtain is rolling up.